Good morning everyone. So in the previous classes we have discussed about how to factorize a quadratic polynomial into the product of two linear polynomial, and that two linear polynomial must be the factor of the quadratic polynomial using factor theorem. Okay, in that classes we have discussed about two examples. Okay, for examples, x square minus 5x plus 6, this is the first one, and the second one is x square minus 7x plus 6. Okay, these are the two examples that we have taken in previous class. And you can see in these two type of examples, the coefficient of x square is 1 here. Here also the coefficient of x square is 1. Okay, and these two type of question or problems are known as type 1 question. Okay, that we have solved in the previous classes using factor theorem. In these classes we will also factorize other quadratic polynomial using the same factor theorem, but the difference is that in these classes we will discuss about type 2 examples. Okay, type 2 examples. What are type 2 examples? In type 2 examples we have basically discussed about or factorize a quadratic polynomial whose coefficient of x square is not 1. Okay, coefficient of x square is not 1. For example, we can take these examples like 3x square minus x minus 4. Okay, see, this is also a quadratic polynomial, but in these cases the coefficient of x square is not 1, it is 3. Clear? So let us start with such type 2 examples. How can we factorize them? And one thing you should keep in mind, all the factorization using factor theorem proceeds with the same procedure. Okay, but there is a little bit difference for type 2. Okay, let's start with. So let us factorize 3x square minus x minus 4 using factor theorem. Okay, we will factorize this equation or factorize this quadratic polynomial. Okay, so answer, since we have to factorize this, that means we have to convert 3x square minus x minus 4 into the product of two linear polynomial. Are you getting my point? Okay, since it is a quadratic polynomial, that means it has two zeros or two roots. Okay, so I can write it has two zeros. What are that zeros? Do you know that zeros? No, we don't know that zeros. We have to assume. Okay, let us assume if a is a root, okay, or you can say 0, and other root is b. We can assume these two zeros. And if a will be a root, then the factor will be how much? As we know, if root is 2, then factor is x minus a, that is x minus 2. Clear? Since root is a or 0 is a, so factor is x minus a. Okay, since root is b, that means factor is x minus b. Now the initial step has been completed. In the initial step we have to convert the quadratic polynomial into two linear polynomial. Okay, and these two factors or these two terms will be the factor of this quadratic polynomial. Now these are the two factors that we are going to find. Okay, so now we can write 3x square minus x minus 4, this is the quadratic polynomial, is equal to. So always keep in mind, whenever we are trying to factorize any quadratic polynomial whose coefficient is not 1, then we have to make the coefficient to be 1. Okay, if it is not 1, then we have to make it 1. How? Simply you can do this by taking 3 as common from all the three terms. Okay, if we will take 3 as common, you can see now x square coefficient will be 1. So we can do this, or we can do the coefficient of x square to be 1 by taking 3 as common from all the three terms. Okay, there are three terms, so we will take 3 as common from all the three terms. Okay, so after taking 3 as common from the first term, Since first term contains 3x square, 3 will be removed out. So the remaining part will be x square. This is clear. Now coming to the second part. In the second part, we have only minus, the coefficient of x is minus 1, but we don't have 3. So what we will do? In that case, you have to divide minus x by 3. I will tell you why you will divide minus 3. I will tell you. Similarly, in the third term, we don't have 3. So what we will do? After taking 3 as common, we have to again divide minus 4 by 3. Okay. Why I am doing that? See, suppose 3 is taken as common from all the 3 terms. Okay. Now I am writing this here. 3 whole into x square minus x by 3 minus 4 by 3. So 3 is taken as common. That means 3 is multiplied with all this term. Okay. Now you can use distributive law here. That means 3 is multiplied with this. Whenever open the bracket, 3 is multiplied with this. Okay. And 3 is also multiplied with this term. When 3 is multiplied with x square, it will be 3x square. Okay. Then minus, when 3 is multiplied with the second term, this is second term. Clear? Now minus 3 is multiplied with the third term. After cancellation, the result will be how much? You can see 3 cancelled out. It will be minus x. Okay. Similarly, 3 cancelled out. It will be minus 4. So the final quadratic polynomial is 3x square minus x minus 4. You can see this equation or this polynomial are same. 3x square minus x minus 4. Are you getting my point? These two quadratic polynomials are same. That means we can write this quadratic polynomial as this. Whenever 3 is taken from all the terms h common, then it will be x square. Since it doesn't contain 3, that means we can divide it by 3. So that when 3 is multiplied with this term, 3 will be cancelled out. Okay. Similarly, since it also doesn't contain 3, then we can divide it by 3. So that after multiplication, this 2, 3 will be cancelled out to give the minus 4. Okay. That's why whenever we are going to take 3 as common from all the terms, 3 will be divided in all the terms. Clear? Okay. Now, it is clear. Now coming to the next step. In the next step, what we will do? In the next step, we can write 3x square minus x minus 4 is equal to. Okay. Now, 3 is the multiplication part. This is the common part. Okay. Now, this is the quadratic polynomial or not? This is the quadratic polynomial, and we have to make this quadratic polynomial into the product of two linear polynomial or into the product of two factors. What are the factors? X minus a and x minus b. That means in place of this quadratic polynomial, we can write x minus a whole into x minus b. Okay. Are you getting? For example, in the previous session we have taken x square minus 5x plus 6. This is the quadratic polynomial. Okay. Since it is a quadratic polynomial, that means it has two roots, a and b. For a we have a factor x minus a, for b we have a factor x minus b. That means this quadratic polynomial can be written in the form x minus a into x minus b. Why I am writing this? Because here the coefficient of x square will be 1. Now you can see here the coefficient of x square will be 1. Okay. That's why this is the quadratic polynomial. For that reason, I am just writing x square minus x by 3 minus x 4 by 3 is equal to x minus a into x minus v. Okay. Now proceed with the same procedure as we have done in the previous session. How? We have to write 3x square minus x minus 4 is equal to 3 is taken as common. Okay. Now x minus and x minus will be multiplied using distributive law. It will be x into x minus b. Okay. minus a into x minus b. Okay. Now 3x square minus x minus 4 is equal to 3 is taken as common. Similarly, inside the bracket it will be x square minus ax minus bx plus a. After multiplication, you can find this result. Okay. So now 3x square minus x minus 4 is equal to 3 whole into x square. You can see these are the two like terms. Since these are two like terms, that means we can take minus as common. We can take x also common. Yes or no? So the remaining part will be minus and x will be taken as common. So it will be a. Since minus is taken as common, that means inside the bracket the sign will be changed. It will be plus b. Okay, plus ab. Okay, so I get 3x square minus x minus 4 is equal to 3 whole into x square minus x whole into a plus b plus ab and bracket. Now we will write 3x square minus x minus 4 is equal to. Now this 3 will be multiplied with all these 3 terms. Okay, using distributive law. Okay, 3 is multiplied with x square, 3 is multiplied with second term, and 3 is multiplied with the third term. So when 3 is multiplied with x square, it will be 3x square. Okay. Similarly, 3 is multiplied with the second term. It will be minus. First write down the constant term, then you will write the variable term. Here the constant is 3, 3 is multiplied here, a plus b also constant, and x is the variable. Now when 3 is multiplied with the third term, it will be 3ab. Now it is completed, the multiplication is completed. Now you can see we get LHS, this is the LHS part, as 3x square minus x minus 4, and RHS as 3x square minus 3 whole into a plus b into x plus 3ab. You can see in both LHS and RHS we have 3 terms. Here 3x square is the first, minus x is the second, minus 4 is the third term. Here 3x square is the first, minus 3 whole into a plus b is the second with x multiplication, and plus 3ab is the third term. So now we will compare these two terms. Why? Because LHS and RHS are equal. So we have to compare LHS with RHS. That means we have to compare the terms of LHS with RHS. Okay? We have to compare the terms means we have to compare the first term with the first term, second term with the second term, and third term with the third term. Okay? So let us compare the first term with the first term. So I can write coefficient, okay, of x square of which part? LHS. You can write LHS is equal to coefficient of x square of RHS. Now you can see in the LHS side the coefficient of x square is 3 is equal to, here also 3. So this is the first equation. Okay. Now coming to the second part, coefficient of x of LHS, I am writing LHS, is compared with the coefficient of x of RHS. Okay, there is a question, why I am doing this? Why I am doing, or why I am equating or comparing the two sides in order to get the value of A and B. Okay. So our main task is to find the value of the zeros A and B. That's why I am doing this. So now coefficient of x is here, you can see minus 1. I am writing minus 1 is equal to, and here minus 3 whole into a plus b. Okay, minus minus cancelled out. You can write it conversely as 3 whole into a plus b. I am writing the second term first and the first term the second. Then what is the value of a plus b? A plus b is equal to 1 by 3. This is equation 2. Okay. Now compare the coefficient of constant. Okay. This is the constant part with the coefficient of constant of RHS. constant. So in the LHS part the constant is -4. In the RHS part the constant is 3AB. Okay, now I write it conversely. So I can write 3AB is equal to -4. Now we will find AB. Okay, A into B. Why I am finding A and B? Because these two are unknown terms. Okay, that's why. So it will be -4 by 3. Okay, this is equation 3. So since we are going to find the value of A and B, you can see the multiplication of A and B will give out or will give out -4 by 3. So we can take possible values of A and B so that we will get the result as -4 by 3. Okay. So now following procedure is possible values of A and B. That means for which value of A and B their multiplication will give out to -4 by 3. Okay. Now let us check that. First let us find or let us take A will be 1. Okay. You can see if A is equal to 1. Okay. Then B will be how much? So that the result will be -4 by 3. First thing is the result is minus. That means we need a minus here. Clear? We need the result as 4 by 3. That means it should be 4 by 3. Because when -4 by 3 or any number multiplied with 1, it will give the same result. Hence the result will be, in the result section I can write -4 by 3. Okay, this is the first assumption. Second, A may be -1. If it is minus, then it is plus. It will be 4 by 3 because -1 multiplied with 4 by 3 to give -4 by 3. Okay, clear? Third assumptions. Okay, you can take A to be 2. Why not? You can take it. Okay, if we will take this as 2, then what should we multiply with 2 to give -4 by 3? Since it is plus, so that it is minus. This is the first thing. Then we need 4 in the numerator. We have already 2 in the numerator. That means we need another 2 because 2 into 2 is 4. So this. Now in the denominator we need 3. So I can write 3. Now you can multiply these two numbers. Let us multiply them. 2 into -2 by 3. This means -4 by 3. Hence the result will be -4 by 3. Clear? Now fourth assumptions. A may be -2. Okay, then B will be plus 2 by 3. So the result is -4 by 3. Okay? And the fifth assumptions, you can take A as 4. I can take A as 4. Okay. If A is 4, then B will be how much? Since we need 4 in the numerator, that means we already get 4. That means we need 1. Since it is minus, so we need -1. Okay. So -1 by 3. So that the result is -4 by 3. Then VI assumptions A may be -4. Okay. So B will be 1 by 3. So that the result is -4 by 3. Clear? So these are the 6 assumptions that may be the result of A and B. And now we will verify out of these 6 assumptions which 2 assumptions will be correct or which holds good, so that we can put in the x minus a term and b term, and so that we can factorize the quadratic polynomial into the 2 linear polynomial. Okay, so let us find them out of 6 assumptions which will be correct. Okay, so now let us check out of the 6 assumptions which assumptions does hold good for the quadratic polynomial. Let us check with the assumptions 1. In the assumptions 1 we have a is equal to 1. Here the term a means this is the 0 of the polynomial, and we know if a term is a 0, that means it will give p of a to be 0. Okay, in the remainder section and factor theorem section we have studied about this. Okay, if this is the 0, that means it should give the remainder to be p of 0, p of a is equal to 0. Okay, and if it gives this result, then we can say yes, a is equal to 1 is the 0 of the polynomial. If it doesn't give that, then we can say no, this is not the 0 of the polynomial. Let's find out p of a. A means here p of 1. Okay, so now p of 1, since this is the polynomial p of x, so put 1 in the place of x. So 3, 1 square minus 1 minus 4 is equal to 3 minus 1 minus 4. 2 minus 4 is equal to minus 2. You can see this is not equal to 0. That means we can say a is equal to 1 is not a 0. We can say a is equal to 1 is not a 0. Okay. So the pair, second pair is b is equal to minus 4 by 3. Let us check with b is equal to minus 4 by 3. So p of minus 4 by 3 we will find. So in the place of x we will put minus 4 by 3. Square minus 4 by 3 minus 4. So 3 whole into 16 by 9 plus 4 by 3 minus 4. 3 1 3 3 is equal to 16 by 3 plus 4 by 3 minus 4. 3 is the denominator or LCM, and 3 is 16 plus 4 minus 12. So the result will be 8 by 3. So here also it doesn't equal to 0. That means b is equal to minus 4 by 3 is not a 0 of the polynomial. You can write it. Now let us check with the assumptions 2. In the assumptions 2 we have a is equal to minus 1. So we will find p of minus 1. Okay. So in the place of x we will put minus 1 square minus 1 minus 4 is equal to 3 whole into minus 1 square is 1. Minus plus 1 minus 4 is equal to 3 1 is 3 plus 1 minus 4 is equal to 4 minus 4, and here we get 0 in the remainder. Okay, since we get p of minus 1 is equal to 0, then we can say minus 1 or a is equal to minus 1 is the 0. Okay, it is the 0 of the polynomial. Let us check with the second pair. B is equal to this is 4 by 3. So P of 4 by 3 is equal to 3 whole into 4 by 3 square minus 4 by 3 minus 4. Okay, so it will be 3 whole into 16 by 9 minus 4 by 3 minus 4. 3 16 by 3 minus 4 by 3 minus 4. Okay. So the LCM will be 3, 16 minus 4 minus 12 is equal to 16 minus 4 is 12 minus 12 by 3, 0 by 3, and here we will get again 0. That means P of 4 by 3 is also 0. Then we can say B is equal to 4 by 3 is also a 0. Clear? So A is equal to minus 1 is a 0 and B is equal to 4 by 3 also a 0. Now remind the first that we have written that this quadratic polynomial can be written as 3 is taken as common whole into x minus a into x minus b. Okay, can you remind it? This is the equation that we will define. Okay, now here we get a is equal to minus 1 and b is equal to 4 by 3. So now put the value of a and b in this equation. Since we will get is equal to 3 whole into x minus a is minus 1. So minus 1 whole into x minus 4 by 3. So the final result is 3 whole into x minus plus 1 whole into x minus 4 by 3. So 3x square minus x minus 4 can be written as the product of, this is the common part. So it is written as the product of two linear polynomials, that is x plus 1 and x minus 4 by 3. And our factorization is completed here. You can use this process to find out the factors of a quadratic polynomial, okay, using factor theorem. But in this type of question, you have to first convert the coefficient of x squared to be 1. How? By taking 3 as common. Okay. So now coming to the question number 2. In question number 2, we have to factorize this quadratic polynomial by factor theorem. That means we have to convert the quadratic polynomial 4x square minus 11x minus 15, okay, into the product of two linear polynomial. Okay, the meaning of the factorization is this, that we have to convert the quadratic polynomial into the product of two linear polynomial, and this two linear polynomial must be the factors of 4x square minus 11x minus 15. Okay, now you can see, since it is a quadratic polynomial, that means it has the degree 2. Okay, that's why it has two zeros. Okay, since its degree is 2, that means it will give 2 0. Suppose we will take, if a b is 0, okay, if a will be taken as a 0, then we can say what is the factor? X minus a will be the factor. Okay, it is the second statement of factor theorem. Okay, now if we will take b as a 0, then the factor will be x minus b. Okay, so this is the factor. So we get x minus a and x minus b are the two factors. It is clear? Now we have the quadratic polynomial 4x square minus 11x minus 15. You can see in this type of quadratic polynomial we don't have 1 as coefficient of x square. Okay, in this quadratic polynomial the coefficient of x square is 4, but we need to convert it into coefficient of 1. How we can convert them into coefficient of 1? Simply by taking 4 as a common from all the terms. Okay, we have to take 4 as a common term from all the terms. Okay, then if 4 is taken as common, then inside the bracket, what are the terms to be written? You can see, if we will take 4 as a common factor, okay, from the numerator of all the terms, okay, then what will happen? Then you have to divide each term by 4. Okay, since 4 is taken as common from the numerator, that is why we will divide 4 in the denominator of each term. Okay, so that the answer will be how much? You can see the answer will be, we can write 4x square minus 11x minus 15. 4 is taken as common, and this 4 cancelled out. X square minus 11x minus divided by 4 minus 15 by 4. Finally, we get this form. But is this right? Let us check. Since 4 is multiplied with all the terms, that means 4 is multiplied with x square, with 11x by 4 and with 15 by 4. Suppose we will multiply using distributive law. So what will be our answer? 4 is multiplied with 11x by 4, okay, minus 4 is multiplied 15 by 4, okay, then you can see it is 4x square, 4 cancelled out, it is minus 11x, 4 cancelled out, it is minus 15. Then we can see one thing, that this equation and this equation, you can see this equation and this equation completely equal. Okay, 4x square minus 11x minus 15 and minus 15. That means only for that reason we are taking 4 as a common, and if 4 is taken as common, then 4 is divided in all the terms in order to balance the two equations. Now you can see this equation and this equation will be same. Okay, so we can convert the coefficient of x square to be 1. Now you can see the coefficient of x square is 1 here. Okay, so suppose if we will take 3 as a common, suppose it is a question 3x square minus 13x plus 4. Suppose this is a question or quadratic polynomial, and here we have to make the coefficient of x square to be 1. How can we convert them? We have to simply take 3 as a common factor from the numerator. So 3 is taken as common. Hence the remaining term inside the bracket will be 3x square by 3. Since 3 is taken from the numerator, that is why 3 is divided in the denominator. Minus 13x by 4 plus, sorry, this is 3 plus 4 by 3. Now we will check, is this right? Let us check. 3 is multiplied with this, 3 is multiplied with this, 3 is multiplied with this. So let us multiply. When 3 is multiplied with 3x square by 3 minus 3 is multiplied with 13x by 3, okay, then plus 3 is multiplied with 4 by 3. See, 3 cancelled out, it will be 3x square. 3 cancelled out, it will be minus 13x. 3 cancelled out, it will be plus 4. Now you can see this polynomial and this polynomial are completely equal. See, 3x square minus 13x plus 4 plus 4. Okay, only for that reason we are dividing 3 in the denominator in order to make the two equation balance. Now you can understand how it is done. Coming to the next step. In the next step, what we will do? Since the coefficient of x square will be 1 here, that means we can write this polynomial or quadratic polynomial as the product of two linear polynomial. Okay, how? Since the factors are x minus a and x minus b. Okay, it is done. Hence, in the left hand side we have 4x square minus 11x minus 15. Okay, now 4x square minus 11x minus 15 is equal to 4. We have to multiply these two factors. After multiplication, they will give x square minus x, okay, minus bx plus ab. After multiplication using distributive law. So 4x square minus 11x minus 15. Now 4 is multiplied with all the terms. Okay. It will be 4x square minus 4x minus 4bx plus 4ab. Okay. Now 4x square minus 11x minus 15 is equal to 4x square. Okay. Now you can see these are the two like terms. Why? Because here the variable is x, here the variable is also x. Here the exponent is 1, here also the exponent is 1. That means the two terms will be like term. Since they are like, we can take common. We can take minus s common from these two numbers or two terms. And what other will take as common? 4 also can take as common because it also contains 4. It also contains 4. Now we can take x as a common. Yes or no? Now what will be remaining in the bracket, inside the bracket? Since minus is taken as common, 4 is taken as common, x is taken as common, the remaining part is a. And I have told you, if minus sign is taken as common, then the inside the bracket the sign of the terms will be changed. Hence it will be plus 4 is taken as common, x is taken as common, the remaining part is b. Okay, plus 4ab. Okay, now this is the equation that you need. This is the equation, you can take it equation A. Okay, this is the equation that you need at the last, because at last we have to find out the value of A and B and put in this equation. Okay, so now we have finally reached at the last of the product. Now we get 4x square minus 11x minus 15 is equal to 4x square minus 4x whole into a plus b plus 4ab. Now this is the LHS part and this is the RHS part, and you can see both LHS and RHS are equal. And I have told you, if LHS and RHS are equal, that means their terms will be equal. That means the coefficient of x square is equal to coefficient of x square of RHS. The coefficient of x of LHS is equal to coefficient of x of RHS. Okay, and the coefficient of constant of LHS is equal to coefficient of constant of RHS. So since LHS and RHS are equal, now we have to compare the terms of LHS with RHS. So let us compare them. So now we will compare the coefficient of x square of LHS with the coefficient of x square of RHS. And you can see the coefficient of LHS of x square is 4 and the coefficient of x square of RHS is also 4. This is equation 1. Now In the second case, we have to compare the coefficient of x of LHS, that is minus 11. So minus 11 is equal to and the coefficient of x of RHS. How can we find the coefficient of x? Simply you can remove x. Now you can see what is remaining. The remaining part is minus 4. So I am writing here minus 4. And the remaining part is a plus b. Okay, whole into a plus b. So this is the coefficient of x. Now write it in the converse way. So 4 whole into a plus b is equal to 11. Hence you can write a plus b is equal to 11 by 4. This is equation 2. Comes to the third equation, in which we have to compare the coefficient of constant of LHS, that is minus 15, with the coefficient of constant of RHS, that is 4a. Okay, write in the converse way. So 4ab, this is the first equation, this is the second equation. So 4ab is equal to minus 50 and a into b is equal to 4 is moving towards the right, it will be minus 15 by 4. Hence we get the equation 3 to be a into b is equal to minus 15 by 4. Now from that equation we will derive some possible values of a and b. Why? Because here you can see the multiplication of two zero, a and b will be minus 15 by 4. Okay, so suppose we will take the value of a to be 1, then I have to find what is the value of b. If I will take the value of a to be 2, then what will be the value of b? Okay, these are the possible values that we need to find first, because we do not know the exact value of a and b, and our target is to find that exact value. Okay, so let us finding the possible values of a and b. Okay, so let us assume, suppose I can take a to be 1. If I will take a to be 1, then what should be the value of b, so that the result will be minus 15 by 4. Since a is equal to 1 and we need negative sign here, so b must be a negative number. Okay, and if 1 multiplied with 15 by 4, the result will be same. Hence the b will be minus 15 by 4, so that the result will be minus 15 by 4. Okay, this is the first assumptions. Coming to the second assumptions, we can take a to be negative minus 1. Okay, so b will be positive because it is negative, that means b will be positive and it will be 15 by 4. So that the result is minus 15 by 4. Third assumptions. Okay, we can take a to be 15. Can we take a to be 15? Yes, if a is 15, that means what is the value of b? First you have to find whether it is negative or positive. So b, yes, it is negative because it is positive. Now in the numerator, in the result section, we need 15. Okay, we need minus, here minus comes. We need 15 in the numerator and 15 comes. That means in the numerator we only need 1, because 15 into minus 1 the minus 1. Clear. But in the denominator we need 4 here. That means we can write 4. Now after multiplying 15 into minus 1 by 4, the result will be minus 15 by 4. Okay, hence it is minus 15 by 4. Then fourth assumption, a can be taken as minus 15. If it is minus, then b will be plus. Okay, so the result will be minus 15 by 4. Or fifth assumption, we can take a to be 2. Okay, a can be taken as 2. Then what will be the value of b if a is 2? How can we find the value of b? Let us imagine. Suppose as we have a into b is equal to minus 15 by 4. Okay, and we have a is equal to 2. So put the value here. Okay, then you can find the value of b easily. How? When 2 is multiplied with b, then 2 moves to the right hand side, then it will be divided because it is multiplied here. So minus 15 by 4 into 1 by 2, it is minus 15 by 8. You can take minus 15 by 8 as b. So b will be minus 15 by 8. So the answer is minus 15 by 4. Okay. Sixth assumptions, a is equal to minus 2, so that b is equal to 15 by 8, because it is negative, that means it is positive. So answer is minus 15 by 4. And in this way we can find more than 6 number of possible values, but I am writing 6 values because I think we can get the exact value out of this 6 assumptions. Okay, that is why I am writing only 6 assumptions, but you can write 10, or the number of assumptions you get, you can write here. Okay, so now we have to find out of 6 assumptions which one assumptions will be holds good for the quadratic polynomial to convert it into linear polynomial. So let us find it. Okay, so now we will check first for the assumptions 1. In assumptions 1, it is given a is equal to 1. A is the 0 of the polynomial, or we can say the root of the polynomial. Since root is given, it means the polynomial completely divides the other polynomial. And according to the statement 2, if it completely divides the other polynomial, then the remainder will be 0. Okay, that means we have to show whether the remainder in this case will be 0. If the remainder to be 0, then we can say yes, it is the root or 0 of the polynomial. Okay, so let us find out the remainder. P of 1, as we have the polynomial p of x as 4x square minus 11x minus 15. So we will put in the place of x to be 1 minus 11 into 1 minus 15. 4 minus 11 minus 15 is equal to 4 minus 26 is equal to minus 22. It is not equal to 0. That means we can say a is equal to 1 is not a 0 of the polynomial. Okay, so a is equal to 1 is not a 0, or you can say root. Now let us check for the second b. b is equal to minus 15 by 4. So p of minus 15 by 4 is equal to, let us put this in the polynomial 4 whole into minus 15 by 4. While calculating such type of polynomial, you should be careful whether to use bracket and whether not to use bracket. Minus 15 by 4 minus 15. So 4 into 15 square is 225 by 16, and minus minus plus 15 11 is 165 by 4 and minus 15. Now 4 cancel, 225 by 4. So I am writing directly here 25 by 4. Now 4 is taken as LCM. So it will be 265 plus 165 minus 15 4 is 60. Okay. So the result will be 270 by 4 after subtraction and addition. So it is also not equal to 0. Then you can say yes, b is equal to minus 5 by 15 by 4 is not a 0 or root of the polynomial. Okay. Now assumption 2, coming to assumptions 2, assumptions 1 doesn't hold good. Okay. In the assumptions 2, we have a is equal to minus 1. So we will find p of minus 1. Let us put in the polynomial. Okay, it will be 4 whole of minus 1 square minus 11 into minus 1 minus 15. So 4 minus 1 square is 1. 4 into 1 minus. And you can see minus minus plus 11 1 is 11 minus 15. 4 1 is 4. 4 1 is 4 plus 11 minus 15. 11 plus 4 is 15 minus 15 is equal to 0. And here we get the value of the remainder to be 0. And also I have told you, if the remainder is 0, then we can say a is equal to minus 1 is a 0 of the polynomial. Hence I am writing here a is equal to minus 1 is the 0. So past 0 we can easily find out. Now coming to the second part, that is b is equal to 15 by 4. So we'll put b is equal to 15 by 4. So p of 15 by 4 is equal to 4 whole into 15 by 4 square, okay, minus 11 whole into 15 by 4 minus 15 is equal to, now 4 whole into 15 square is 225 by 16 minus 165 by 4 minus 15. Okay. Now 4, 16. So I am writing here directly 225 by 4. Now 15 is, so 4 is taken as LCM. 225 minus 165 minus 15 for the 60. So 225, this 2, same sign, that means they can be added, and 165 and 60 added to give to minus 225 by 4, and 225 minus 225 is 0 by 4, that means answer is 0. And here we get the second 0, then we can write yes, b is equal to 15 by 4 is also the 0. Hence, we can reach at our destination, that we have to find out the value of the 0, and we get 2 zeros here. Now let us put them in the original equation. This is the original equation. What is the equation? 4x square minus 11x minus 50 is equal to 4 whole into x minus a into x minus b. So in the place of a and b, we have to put this to value. Hence our equation will be 4x square minus 11x minus 15 is equal to 4, okay, whole into x minus a. You can see a is minus 1, okay, into x minus b. Clear? Now it will be 4 whole into x minus minus x plus 1 whole into x minus 15 by 4. This is our answer. Hence, we can say the quadratic polynomial 4x square minus 11x minus 15 can be converted into the product of two linear polynomial, and these two linear polynomial will be the factors of 4x square minus 11x minus 15. Okay? Are you understand?